All right, let's talk about an energy source that sounds like it was pulled straight from a sci-fi novel. It's called thorium. And honestly, it has the potential to completely flip the script on everything we thought we knew about nuclear power.
I mean, just think about that for a second. What if we could have all the benefits of clean, powerful nuclear energy, but without the baggage, without the biggest, scariest downsides we always hear about? It's a heck of a question, right?
Well, here's the thing. That fuel is not a fantasy. It's absolutely real. And a massive amount of it, a possible key to our entire energy future, is just sitting there, hidden in plain sight along the coast of Egypt, mixed into its famous black sands. So, what's the big deal with thorium? Why is everyone so excited about it? Well, to get it, you've got to understand one critical idea. Thorium isn't what we call fissile, it's fertile. And trust me, that one little word changes everything.
Okay, so here's how that works. Your standard nuclear fuel, uranium-235, can split and start a chain reaction all by itself. Thorium can't. It needs a little kickstart first. It has to absorb a strained neutron. Then, and only then, does it transform into a brand new super-efficient fuel called uranium-233. So think of it less like a log that's already on fire, and more like a special kind of wood that can be turned into the perfect fuel. All right, let's put these two heavyweights in the ring together. When you really compare thorium to the uranium that powers pretty much all of our reactors today, the differences are, well, they're stark, especially when you start talking about safety. And the numbers don't lie. Just look at that melting point. Thorium dioxide can take more than 500 degrees Celsius of extra heat before it even thinks about melting. That gives you a massive, massive safety buffer against a meltdown. Plus, it's better at getting rid of heat and it's chemically stable. It doesn't really react with air or water. It's just a fundamentally tougher, safer material.
But the good news doesn't stop there. One of the biggest headaches for nuclear power has always been the waste. What do we do with this stuff that stays dangerous for thousands of years? Well, on this front, thorium is a whole different story.
The difference here is just staggering. We are talking about hundreds of years versus tens of thousands of years. After about 400 years, thorium waste is basically as radioactive as the dirt you dug it out of. That's a problem we can actually manage on a human timescale, not some toxic legacy we have to pass on for 300 generations.
Now, safety and waste are huge deals, for sure. But this next part, this might be thorium's ultimate trump card. It has a built-in, physics-based feature that makes it incredibly difficult to turn into a nuclear weapon. It's all thanks to this neat little chain reaction. See, when you make that amazing U-233 fuel, you also accidentally create a tiny bit of a contaminant, uranium-232. And as that U-232 breaks down, it creates something called thallium-208. And this stuff, this is the secret sauce. It's basically a built-in security guard. Why is it a security guard? Because it blasts out these incredibly powerful, hard-to-shield gamma rays. We're talking 2.615 mega electron volts of pure energy. It's like a constant screaming alarm bell that tells the entire world, hey, I'm over here. So, what does that actually mean in the real world? Well, for one, this radiation makes the material so deadly you couldn't get near it without massive, specialized robotic gear. It's also so loud, radiologically speaking, that satellites could spot it from space. And here's the final checkmate. Those same gamma rays would literally fry the delicate electronics you'd need to actually detonate a bomb. It's naturally proliferation-proof. So, now we know just how incredible this stuff is. Let's circle back to where we started, to that treasure buried in the sand. Let's talk about why Egypt is in such a unique and, frankly, powerful position for the future of energy. For thousands of years, the Nile River has been washing minerals down from deep within Africa and depositing them on the coast. And over all that time, the waves and currents have acted like a giant sorting machine, concentrating all the heavy stuff, the good stuff, along this huge 400-kilometer stretch of coastline. And locked up in all that sand is a pretty staggering figure. Egypt is sitting on an estimated 6.25% of all the known thorium in the entire world. Now, that number might not sound huge, but in the world of strategic resources, believe me, that is a major piece of the pie. It puts Egypt right at the center of the conversation. Now, you don't just find pure thorium sitting on the beach. It's locked inside a mineral called monazite. But here's the cool part. Monazite is like a treasure chest all on its own. It's also packed with rare earth elements, the stuff you absolutely need for electric cars, wind turbines, and all our high-tech gadgets.
It's like a two-for-one deal. So, the billion-dollar question is, how do you get from a scoop of sand to a high-tech nuclear fuel? Well, the process is this really cool mix of just raw power and some very clever chemistry. Let's break down how they unlock this treasure. It all starts with these massive dredges, just scooping up thousands of tons of this black sand. Then they use these really smart techniques, using things like spirals, magnets, and static electricity to physically separate out the heavy monazite. And the final step is where the real magic happens. It's a chemical process they call cracking, where they use powerful acids to basically break open the mineral and set the thorium free.
Okay, I know exactly what you're thinking right now. If this stuff is so perfect, safer, cleaner, more abundant, then why on earth aren't we using it everywhere? Well, the road from a brilliant idea to a global energy source is paved with some really big, really expensive hurdles. And this quote pretty much nails it. For the better part of a century, we've poured trillions of dollars into building a massive global industry, all centered around one thing: uranium. Trying to switch to a completely new fuel is like trying to turn an aircraft carrier on a dime. It's a monumental task. So let's look at the roadblocks. First, the cost. You'd have to build an entire supply chain from the ground up. Technologically, the best thorium reactors run incredibly hot, which really pushes our current materials to their absolute limits. Then you've got all the red tape. Every nuclear rule in the book is written for uranium. And finally, you have this little chicken and egg problem. Remember how thorium needs a kickstart? Well, that means you still need a little bit of uranium or plutonium to act as the spark plug to get the whole thing going. Which brings us to the big final question. Is thorium really the future-proof fuel we've been looking for? The key to a cleaner, safer nuclear age just waiting to be dug out of the sand? Or are the challenges, the money, the technology, the politics, just too big to overcome, leaving it as a brilliant idea that's always just over the horizon? The science is solid, but the answer? Well, that's going to come down to money, engineering, and sheer political will.